So this is the 11th question on Millmans theorem which we will be discussing. So this circuit, like the previous one which we have discussed, the previous question, it is a mix of both kind of arrangement, parallel voltage sources and parallel current sources. So like we did in the previous case, here we can go with the Norton approach, okay, Norton equivalent circuit approach or Thevenin equivalent circuit approach, and both will include source transformation. So first let us go with the Norton approach. Okay, so here in order to find out the Norton equivalent circuit, we have to convert this voltage source into current source because there is already a current source present. So this current source will be 12 volt by 2 ohm, that will be 6 ampere, plus followed by minus, that's why current direction is upward. Then we will shift this 2 ohm resistor connected in series to parallel with this 6 ampere current source. Then we have this 4 ohm resistor, remaining circuit will stay the same, 4 ohm, then the 4 ampere current source, then again the 4 ohm, and then finally the load resistance 9 ohm. So across these 2 points we have to determine the Norton equivalent circuit. So that will be something like this. Rn, In, there we have the 9 ohm. So here In is simply the sum of the currents, 6 ampere plus 4 ampere, both are in the same direction upwards, that's why plus, that's why it is 10 ampere Norton current, that is 10 ampere. Rn is simply 2 parallel with 4 parallel with 4 up to these 2 points, okay, these 2 terminals, 4, 4, 2, they are all connected in parallel, that's why it is like this, 1 by 2 plus 1 by 4 plus 1 by 4, which is equal to 1 by 2 plus 1 plus 1, which is equal to 1 ohm. So Rn is equal to 1 ohm. Okay, so you've got both Rn and In. Now this current I, we have to apply current division rule to determine this current. So it will be I is equal to 10 ampere into 1 divided by 1 plus 9, which is equal to 10 into 1 by 10, which is equal to 1 ampere. So this current here flowing through the 9 ohm resistor is equal to 1 ampere. Okay, this current is equal to 1 ampere. Now let us see if we go the Thevenin equivalent circuit approach, whether we'll get the same result. We'll get the same result, but let us confirm it. Okay, so here for that, the same circuit, we have to convert this 4 ampere 4 ohm combination, current source and resistance combination, to this form, voltage source connected in series. So that will be simply the product of this current and resistance, that will be 16 volt and 4 ohm connected in series. Okay, so that will be something like this. Okay, so here in this way it will be first 2 ohm 12 volt, let us use a different color. Okay, first it is 2 ohm 12 volt, then we have this 4 ohm and 4 ampere, so that will be 4 ohm and 16 volt. Okay, 4 ohm and 16 volt. So now I have placed this polarity plus minus because here the 4 ampere is directed upwards. If it would have been downwards, then I would have placed the polarity minus plus. So because the current direction is upward, that's why I placed plus minus. Next we have is this 4 ohm resistor. So it will remain as it is. And then we have the 9 ohm resistor. So across these 2 points we have to determine the Thevenin equivalent circuit. This is 9 ohm, this is VTH, this is RTH. So here if you see, this here is V1, this here is V2, here there is no voltage source, that's why V3 will be 0 volt, this is R1, this is R2, this is R3. So VTH is simply V1 by R1 plus V2 by R2 plus V3 by R3 divided by 1 by R1 plus 1 by R2 plus 1 by R3, which is equal to 12 by 2 plus 16 by 4 plus 0 by 4, because V3 is 0 volt, it is 1 by 2 plus 1 by 4 plus 1 by 4. So this is 6, this is 4, that is equal to 10 by, here it is 4, this is 2 plus 1 plus 1, so this is 10, simply VTH is 10 volt. Okay, VTH is 10 volt. RTH will be the same thing as RN. RTH will be the same thing as RN, because here also when we short circuit the voltage source, the Thevenin equivalent resistance will be simply 4 parallel 2. Here also the same thing, to determine the equivalent resistance we have to open circuit the current sources. The same thing, RTH and RN, they will always be the same. I have already discussed it in while discussing the Thevenin and equivalent Thevenin and Norton equivalent circuits, the interconversion between them. So RTH and RN, they are the same, and here that is equal to, we have calculated 1 ohm. RN or RTH, that is equal to 1 ohm. So here this current I is equal to 10 volt by 1 ohm plus 9 ohm, is equal to 10 volt by 10 ohm, which is equal to 1 ampere. So here also, using the Thevenin circuit approach, we determined I equals to 1 ampere, current flowing through the 9 ohm resistor, and using the Norton equivalent circuit approach also we determined I is equal to 1 ampere here. Okay, so it depends, it is entirely upon you which approach you are comfortable with, whether you are comfortable with the Thevenin approach or the Norton approach. Okay, so this is the 11th question related to Millmans theorem which we have discussed. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.